Good morning, Internet. I am here in my office in Virginia Beach, Virginia, and we're here for another live Docker Q&A on YouTube, obviously, because, you're on YouTube. So I need to get better and fancier at that intro, right? We need to get like a slide in, a fancy little thing that comes like, pew, in from the side, and then like some sounds. But that'll all happen in time. Right now, let's just focus on the Q&A. So today we've got. By the way, yesterday I launched a whole bunch of new stuff on my Swarm Mastery course. There's like 2+ hours of content that are on Swarm updates and service rolling changes and rollbacks and all that sort of stuff. So I'm going to put that in chat. And then I've got a couple of interviews, actually. An interview where I was at Docker headquarters, and I got to interview one of the engineers on the Swarm team, and we'll hopefully get that posted in the next couple of weeks on YouTube. So make sure you subscribe on YouTube if you want to get a notification about that. And away we go. Let's jump into the Slack chat, or I'm sorry, into the YouTube chat. And if you are in the Slack chat, just so you know, I'm only going to pay attention to the YouTube chat because we got too many chats. And I will probably ignore any Twitter questions or any Slack questions, and I'll only be going through the Q&A on YouTube because we got a lot there. So first, we start off with Stephen. Hello. Good morning. At least where it's morning. Says, I need to convince my workplace that a move away from VMs and into containers would be a good move. Have you encountered similar restrictions before, resistance before, and how do you overcome it? I appreciate this is extremely subjective, but I'm looking for the big headliners. So the way that I think any good technology gets adopted in a company correctly is because it solved a problem. The way I think it often, in a good or a bad way, gets implemented badly is because of hype. And so I always recommend, when I was running engineering teams and data centers, not that long ago, we would often take a piece of technology and, assuming that I could get a trial or something open source or something like that, we would try something that did not need management approval, like a small little server that was only for the people in my team. Like maybe it was a monitoring tool that provided some sort of automation for monitoring that we only really cared about. And we would go and use that tool or figure out a way to use that tool, whatever it was, in a capacity that did not affect customers directly, did not affect our managements, it did not add risk to management so they would be upset if they found out later, or at least too upset, because they might get a little upset. But I would say that the management chain obviously is very critical. So for most consulting projects of Docker, the saying sort of go, and this is true of any IT project, you need to have a technical lead and a chief level, or hopefully someone close to chief level, a higher VP of some sort, that's willing to back you up. And that could be not necessarily an IT level person. That could actually be a client or a customer that's interested and willing to take the risk with you on a particular project. If you're at that level of a company where you can affect customer projects and stuff like that, then I would say it. The next thing is a lot of Docker's advantage over like all the other technologies that we've all adopted over the last 15 years is that it solves a lot of problems for a lot of people, not just a server. It solves a lot of problems for developers, for example, on your local machine without affecting anything else outside that machine. It can make developer environments really easy to use. Docker Compose makes it really easy to spin up environments up and down all day. So you could implement that on your own machine. I assume that you would have the authority to do so. If you don't have the authority to install software on your own machine, you're already in trouble, and maybe look for a different job. But you should be able to do that there. And then I've seen environments, I'd say the majority of cases that one developer uses it locally, gets a second developer to use it locally. They both like it. They get a third developer to use it locally. And then eventually oh, let's try it on a server. They don't go for servers day one. It's rare that operators like myself are the first in a company to adopt Docker. I wish more operators would adopt it first and to be the ones to say, hey, developers, here's some really cool stuff you should try out. Because usually it's the developers bringing the cool stuff or making the cool stuff. So I would say that, plus the other thing, the last thing I'll say on this question before we move on, because it's a great question and I could talk for a long time about it, is in this YouTube channel, there's a new video called Why Docker, Why Now? That is based on my slide deck for pitching management on why they should consider a project for Docker. And every project that you start with Docker, like the very first project, should be very, very small. I don't care who's involved or who's excited about it. And you should wait to see real benefit in that small little project before you start putting it anywhere else. That's to get rid of the fear, uncertainty, and doubt, the FUD, right? And that slide deck on that video in this Slack channel will take you through the slide deck as well as me explaining the reasons why I think, and almost all of those reasons are management-worthy reasons. Most of them focus around huge benefits in developer productivity and speed of deployments and money, and all that stuff. So check that stuff out, and good luck. All right, Sujay, you can't totally move away from VMs, but at least reduce their footprints in your data center. There is a video from DockerCon by Lee about how to build your container strategy, and then from Docker Captain Nirmal. Nirmal is awesome. About a strong belief loosely held, bringing empathy to IT. Oh, you're giving recommendations to Stephen. Great. And right. That's true. You did say convince my workplace that a move away from VMs into containers would be moved. Yeah, so, right. A good point. You're most certainly not at first going to move away from VMs to containers. You're going to be in containers in VMs. And then eventually, this is actually a part of my DockerCon 2017 talk called Journey to Docker Production. If you look that up on YouTube or on brettfisher.com/Docker, I'll put that in here. Basically, everything I do, I try to put on brettfisher.com/Docker. There's a video there where I actually go through some details about the pros and cons of going bare metal with Docker versus a VM with Docker. I would say that overall, generally, bare metal is way faster, but we have all just spent the last 15 years going to virtualization away from bare metal, and so convincing an organization that they need to turn around and go right back is usually a very bad, it will not go well. They will probably not say yes right out of the box because they probably built an entire team of people around managing virtualization and products and spending hundreds of thousands of dollars on VMware and all that stuff if you're a big shop. And it will be hard to go right back. But I think at the end of the day, long term, it's the right choice is a mix of both. It's still way faster to deploy a VM than it is a bare metal unless you're a really, really advanced shop. So that was one of the problems we were trying to get away from in the first place was bare metal was very slow to implement. When will it start? Augustine says it started late, like maybe 2 minutes late. Natish, by default, a Docker container is restricted by C groups up till what amount of RAM CPU storage? What good options out there are for backup recovery and Docker for product? Okay, so, these are two questions. Sorry. Natish, a container is restricted by C groups until what amount of RAM CPU storage? So, I think what you're asking about are resource limitations and resource reservations, maybe even in Swarm. So a C group by default gives every container and every app on a Linux machine access to the total amount of RAM and CPU and disk I/O and network I/O that the machine has, right? C groups exist in Linux before Docker. They're used in Linux before Docker. Docker just takes advantage of them for controlling, as well as namespaces, for controlling resources and other restrictions on the OS to give it that little bitty location, right? So if you're considering going to production, I always recommend you put limits and restrictions, limits specifically, that's the actual Docker term, limits. And then in Swarm, you can actually do reservations as well as I believe you can do that as well in Kubernetes. You can set reservations so that you ensure you have the resources you need. Limits will prevent your apps from using more than they need. So you would always do those in every service or every container on a production server, because in the VM land where we used to be, you would normally run one application in that VM. So you would run MySQL. And if you did, MySQL would eat up all the RAM, because that's MySQL's job, is to eat up all RAM and cache everything as much as possible. In a container, if you're putting more than one container on the host, and you probably are, you're going to need a limit on that, or it's going to eat up the resources. And then the other applications in containers, like another MySQL or a web server or something, those are not going to get resources. And so you're going to have problems. It's only a matter of time on any production server before someone realizes they need to put limits on all their containers. So you can do that right at the command line, Docker run. We can actually go more advanced this week, and I also remembered how to change screens. So if you did Docker run, so you can see here, there's some limit options, some other ones. If you just grep CPU, you can see a whole lot of CPU options on there. I won't go too into this for now, but the right one to use is --CPUs. CPUs. That's the modern way to do it. All the other options are sort of, I would say, legacy at this point. They were features that Docker had added in, and because Docker tries to be backwards compatible as much as possible, they're not going to take the old ones out. I wish they'd indicate in some way that that was the preferred one, because the other ones all had pros and cons in the way you implement them and their complexity. But CPUs is really easy. You basically just say, if you want one CPU, put 1. If you want a half a CPU, put 0.5. That sort of thing. So if you want all 4 cores in a machine that it has 4 cores, put 4. That's kind of how that works. Kevin Griffin says hi. Hi, Kevin. How you like my new camera? Is that fancy? Where it's like blurry in the background. It's got that fancy lens. I'm learning. Niraj, I think is how I say that name. Sorry if I messed up your name. Question. I have been to a container conf recently and no one talks about Swarm. Everyone talks about Kubernetes. So what is in Swarm that's not in Kubernetes? Also, why not a K8s course by you in Udemy? Those are all great questions, and I get that the first question, Swarm versus Kubernetes, every time I do a conference or workshop or anything. So it used to be why Docker versus something else, and that I think Docker pretty much won that war. And in fact, I was talking the one time I got to meet Kelsey Hightower, who's one of the famous people on the Kubernetes and Google side, and he said, you know, we were talking about the engine or the runtime, I think, and he's like, Docker won that war, right? Like, there's no war; they just won. Everyone does it because we've had a couple of experiments at runtime, Cryo and Rocket and stuff like that, and those are good. But luckily, we settled on a standard. At the end of the day, I don't care which orchestrator you use. I don't care which runtime you use. I want you to use what solves your team's problems, right? If you would hire me as a consultant, I'm going to look at ways to get you to use Swarm first. And the reason is actually explained in my AMA. So I have a GitHub AMA that I will pull up. And in here, you can actually just search for Kubernetes, and there's only one question so far. It goes through a bunch of stuff. So that's issue 6, and I'm going to put that in here. I'm not going to repeat it all, but I will summarize it. I think right now, for every team that wants to implement container orchestration, there is a lot of factors. What cloud you're on, whether you're going to be in the data center, whether you're going to be more web services, or you're going to do a lot of legacy applications, are you going to do a lot of persistent applications, are you going to be worldwide, but most importantly, of all those technical things, Do you have one person that's going to do this job or a team of people that will do this job? And by the job, I mean managing Docker and Docker orchestration. So if you are a one-person shop, meaning like you are the only person that's going to be responsible for this, the only way I'd recommend Kubernetes is through a higher level tool like Docker Enterprise Edition or Amazon Fargate or Rancher, or I would even recommend OpenShift because I'm just generally not a Red Hat. Well, first off, I'm not that smart in it, so I can't recommend something I don't know. But if you're a Red Hat shop, you know who you are. You're going to use OpenShift. Fine, it'll work. But on the open source side, Docker EE is obviously the paid version of Docker CE, so it gives you much more features. But the biggest problem with Kubernetes out of the gate right now is its complexity of deployment and management. Everything takes more work and more effort and more, for example, the YAML files are going to be 3 or 4 times bigger than if you had Swarm. The Swarm commands are very simple. The Kubernetes are not. In all cases, some of the Kubernetes commands are fine. And the Kubernetes deployment is more things to manage. You've got a lot more services to concern yourself with, a lot more things you've got to check. Swarm is just, you're already running Docker, so you're just basically enabling an extra feature in Docker. So I always advise teams up front for Docker Swarm if I feel like they're small team, small complexity, they're not trying to deploy 5,000 nodes, because most of us are not. Most people I talk to are doing five nodes to 50 nodes, because really you can scale those nodes up. You can make them as big as you want, right? You can have, 64 core server and have 10 of them and deploy an entire data center of infrastructure on 10 Swarm servers. So I always try to make people's infrastructure as simple as possible, because at the end of the day, as a consultant, unlike some consultants that just want a job, I don't want to be your consultant forever. I want to help get myself out of the job so you can manage your solution on your own. I'm the sort of teach you to fish kind of guy. So I got other things I want to do, right? So I want to go do those things. So that incentivizes me to give you very simple as infrastructure that's as simple for you to manage as possible. Swarm is the answer to that. So typically what I do is I go through a workflow where we try to figure out, can we do Swarm and will it meet your needs? And if not, then we'll consider Kubernetes at that point. But usually I will not even recommend Kubernetes if they don't have at least 3 people that are going to manage this infrastructure full time, because if you only need 10 servers and you're only going to run web apps, I feel like Kubernetes you don't need that. It's too much. You can just use Swarm. It works great. If you need more complexity, okay, let's in certain things, if you need compatibility with third-party tools, if you don't want to pay for Docker EE, but you need AD authentication or RBAC, role-based authentication, then you could probably do, nowadays you could do not Swarm Pit. What's the other one? Portainer. You could do Portainer nowadays, portainer.io on top of Docker Swarm. That gives you a role-based authentication, but you might choose Rancher, which does Kubernetes because it does role-based authentication. So anyway, I get into the weeds on that, but it does get very, very complicated, and there is no right or wrong answer. The reason that most people are not talking about Swarm is because, quite frankly, it's easy to use, I think. If you look at reports like DigitalOcean, they just put out a report this quarter. In fact, I just talked about it last night in my newsletter. I think it's Currents. Yeah. And if you look here on DigitalOcean specifically, which I would consider smaller teams, less complex infrastructure, less enterprisey infrastructure. Shoot, where's that? I think I passed it. Yeah. Container orchestration platforms primarily used. Kubernetes is number 1, and you might argue that OpenShift, while it is a fork of Kubernetes, is also Kubernetes. So if you added those together, you get 47% Kubernetes, 35% Docker Swarm, and then it goes down from there. I think those numbers will be drastically different if you went to AWS, where Kubernetes will probably reign supreme. I think those will be drastically different if you went to a data center, where I think Mesos is going to be a big winner, especially in telecom. Mesos will be a much higher implementation. Also, Red Hat inside a data center will be much higher. So my point here is that there are lots of choices. There is supposed to be lots of choices. We don't want just one choice. And I advocate the right one for you. And of course, the hard part is just figuring that out. And like any other tool, do we use Chef or Puppet or Ansible or SaltStack? Do we use AWS or Azure or DigitalOcean? Those are all infrastructure decisions that take research and testing. And unfortunately, I can't give you a black or white. I'm a fan of Swarm for teaching and for teams starting new, because that, I think, is really easy to get going on. And then later, if you figure out, yeah, we've got some needs that Swarm isn't meeting, maybe we either buy Docker EE, because that can do Swarm and Kubernetes, or maybe we're going to switch to a pure Kubernetes platform. I do not, last thing I'm going to say on this, recommend upstream raw Kubernetes. Even the authors and owners or maintainers and creators of Kubernetes do not recommend that you do just raw upstream Kubernetes. That's what I mean by, forking the repos and implementing it that way. A lot of websites teach that because they're teaching it as a way to understand how Kubernetes works. That does not necessarily mean that's how you should deploy it in production, because Kubernetes was designed for higher level tools on top of it, like Rancher, Docker Enterprise Edition, Fargate, OpenShift. All these higher level tools were there to help you deploy and manage it. And even the creators were saying this raw tool called Kubernetes was really meant more for system builders and for people to build higher level tools on top of, not necessarily the only thing you run. So that'll be my last thing there. Great question, and one I'm clearly passionate about. What I don't want you to do is choose something because someone told you to, or because of the buzzwords on the internet, or because you thought it was more popular because it's better. I don't know right now that we really have one that's a clear better. Kubernetes has obviously won the hearts and minds of the internet, but it doesn't mean it's the right choice for every team. Oh, my chat is moving by. All right, Jan. Hey, Brett. How do you deal with storage when you have a stateful application in the Swarm cluster? So far, I am using rsync variant and distributed SQL to be able to run SQL and real-time apps. I'm not sure if you're. So the answer in Swarm is to use a volume driver. A volume driver. You've been using volume drivers all along with Docker and Swarm. You may not have known it. When you do a Docker volume ls, you actually see a driver. Let's go there, right? If I do a Docker volume ls, see how it says driver local? That's the default driver. That's the only one, unfortunately, that comes with Docker out of the box. It just means I will create a volume space on the host that my container is running on, and I will store the data there. In Swarm, you've got to worry about your containers potentially launching on multiple nodes. Not multiple nodes, on one node now and another node later, right? So that's when I recommend RexRay. RexRay is the best open source project for having a storage orchestrator. A storage orchestrator runs at a lower level. It runs at the sort of the same level as Swarm, and it schedules the volumes where they're needed by containers. It's designed to use with third-party storage. So we will call that shared storage. Storage that is not on your host. It does not replicate. It just connects external storage to where it needs to go. The big complexity that people trip up on with is, first they figure out, oh, I need RexRay because I'm in a Swarm. Personally, if I'm going to do anything persistent in a Swarm, I'm going to use RexRay first, because it works in the cloud, it works in the data center with all of the storage that I need. But you have to consider the storage itself, because Docker can't change the way your storage works. If you're using EBS, AWS's EBS solution, EBS does not allow storage to connect to two EC2 instances at once. That is not a feature of EBS. EBS is about connecting one disk to one server. So you can't change the laws of that. just because you're using Rexray or Docker. So if you want two servers to use the same volume for shared, maybe they're both accessing the files at the same time. Maybe it's a user upload directory where you're uploading user data. Or maybe you're using a blog and you want the blog theme and the blog uploads to be on shared disk. In that case, on Amazon, for example, you would use Rexray with EFS, Elastic File System, I think, right? EFS. And EFS itself natively allows multiple hosts to talk to it at the same time because it's basically NFS on the network. So it has that built in. The reason I'm saying that is because people think that Rexray somehow is going to make their storage do things it can never do before. And that's not true. What Rexray does is automate your storage to make sure that it's connected to where it needs to be when it needs to run. And if you lose a container and you have to spin up that container somewhere else, Rexray's job is to disconnect that volume and move it to where you need it. It won't make new features out of your storage. So if you need replication and you don't have storage that is shared storage and you just need host-to-host replication, there are several options. I actually keep a list under storage because I cannot remember them all. One, let's see, one I would recommend, Portworx. Portworx is a paid product. It's free for 3 servers, but if you're in a business and you're trying to do storage, I recommend that you consider Portworx as a part of your solution, even if you have to pay for it, because data replication is really hard, and to get it right in a container orchestrator where things are moving around dynamically is even harder. So you may not want to put a bunch of risk into that by using something that's maybe untested as some sort of third party, as some sort of open source hacky solution. Obviously, not all open source solutions are hacky, but let's look here. There's storage. I have not used them yet, but I have tried them in a demo. There's STORIDGE. I'm not sure if they actually do replication though, so you'll have to check them out. Hedvig, might want to check them out. I'm not actually sure if they do replication either. There are a couple of open source ones, but the real challenge with what was the other one I was looking for? Yeah, there's stuff like I've looked at rclone and OpenEBS and stuff like that. The real challenge there is that you have to get the storage solution to work, and then you have to get it to speak Swarm, because it has to know where it has to talk to the Docker API and be able to connect your container solution, which is changing all the time, to the storage. So not all the solutions that exist for data replication are automatically going to work in Swarm. My recommendation is if you're a small shop or a single person, don't do persistent data if you can avoid it. Put it on Amazon's RDS or someone else's problem. In other words, I love swarms where I don't have to worry about any persistent data, especially database persistent data, because then I have to worry about database clustering, which is not solved by Swarm or anything else. I'd rather use RDS or some solution where the hosting company gives me a really cheap database solution, and then I can put that outside my Swarm and then just spin up stuff in my Swarm for web services, worker jobs, websites, stuff like that. You may not get all those choices, but good luck. Any thoughts on OCI? VJ says, great question, by the way, Jan. VJ says, any thoughts on OCI? Not specifically, but if you had a very specific question about it, then fire off. It's a standard, right? Curious what your thoughts are. Robert says, hey, Brett. Oh, by the way, if you haven't noticed, I started this morning with a Red Bull, but now I've got coffee in a Guinness mug. So I'm a beer and coffee fan. So, Robert, Hi, Brett. Just out of interest, is this C group stuff, limits reservations covered for or going to be covered in your Docker Swarm Mastery course? Yes, it is currently covered in the course. I have already completed your Docker Mastery course, but can't remember this being covered in Docker Mastery, at least not in detail. I'm sure you mentioned it. So I may or may not have mentioned it in Docker Mastery. Docker Mastery was more about the toolkit, the verticals of Docker tools that you would need for local development and for beginning your journey on a server into production, right? I could not fit all of the possible solutions for production into a 9 to 10 hour course. And I really don't want to make like a 40-hour course because that would just kill me. So I realized that I needed to make multiple courses and split it up in order to focus on certain subjects. So I recommend Docker Swarm Mastery to anyone who's going to take Swarm into production, because you can get away with the knowledge I have in Swarm in Docker Mastery, the first course. You can do that for CICD or testing or playing around, and that's probably all you need. If you're going to do like 3 nodes on DigitalOcean for your own personal projects, it will totally work. But if you want bigger solutions, more complicated solutions, if you want to know about third-party monitoring and logging and all that stuff, that's where Swarm Mastery jumps in. And I'm actually still finishing that course up. We're working right now. We just finished a section, just launched it yesterday, on all the ways of doing rolling updates, zero downtime updates, rollbacks due to failures, health checks. And then the next section that we're already working on is Prometheus monitoring, with getting metrics out of your system and how to run the metric system inside of Docker Swarm, and also gather the data out of Docker Swarm so that you can take action based on your success or failure in monitoring. So yeah, check that out. Great question. Gideon, hi Brett, hope that I'm pronouncing your name correctly. Do you have any advice on which storage driver to use? AUFS, device mapper, etc. So if this is assuming you're using 1806. This is a great question. So storage drivers are something for more advanced people to get into, unless you're on Red Hat, and then you have to deal with it on day one. Because normally Docker will choose for you the right driver out of the box. And the way it chooses is it has a preference for what it likes in terms of the best storage driver, and then it will also look at your operating system to make sure your operating system can support that. And if it can't, it has this list that it goes through. Can I run this one? Can I run this one? If you're not aware what a storage driver is, it's not a volume driver. It's at a lower level than the volume driver. A storage driver runs, and those layers of images and the read-write layer on top of that your container runs, that when you all learned your basics around Docker, you learned about the layers of the image. Those are all stored inside of a file system on your Linux OS that uses something called a storage driver. And that also rides, usually, not always, on top of the native file system on your host. So if you have a Linux machine and it's using, let's say, what's the default one in Linux? Let's go look. Let's actually do a Docker info, and we'll look at what's on my machine. So on this particular one, because I'm on Docker for Mac, my native file system is running extfs, or ext, right? Ext is how the partition is formatted, and then on top of that, there's a driver that Docker enables called overlay 2. That is dependent on a lot of things in your operating system. I'm going to assume here you're running the latest version of Docker, 1806. That's the latest stable release, the latest edge release. It's released on Windows and Mac and Linux. So assuming you're doing that, Docker is almost always going to choose overlay 2 for you, because it now has all the features and performance advantages of just about every other driver out there, and all the work is being put into that. 4 years ago, 3 years ago, we had lots of options and different people chose different things. I no longer recommend AUFS. I no longer recommend any of the other drivers. I always recommend overlay 2, unless you're on Red Hat. If you are on Red Hat Enterprise Linux, I believe still your default choice and only choice, or best choice, is Device Mapper. Device Mapper is Red Hat's preferred driver. They put their own effort into that. They develop that and put commits into that code to make it better. The only negative around device mapper is that, well, and it might be a plus or minus depending on how you look at it, is that out of the gate, it works really slowly because it's using sort of a loop back method to use the local file systems right here. What Device Mapper wants to do in Red Hat is it would prefer that you set up a separate dedicated partition for your images and your read-write layers of your containers on top of that. So it usually means that if you're a Red Hat person, you got to go through extra efforts of setup in order to get your device mapper going, because you don't want to use that default setup. It is, at least it used to be, much slower than a native solution like Overlay 2 or something like that. So that would be my recommendation, is always try to get yourself to the latest version of Docker, number one, because that's the most important. And then number two, use Overlay 2, which is the default. It's now the default on every install unless you're on Red Hat. The only reason it might not be default is if you're on a really old kernel that doesn't have Overlay 2 support built in, because it depends on the kernel. And in that case, it might force you back to AUFS or something else. In that case, I would say get newer kernels, get updated so that you can take advantage of the latest stuff. Great question. Storage drivers. Alex, you know what? You said you skipped my question. I may have skipped your question because I'm looking at Top Chat and I just realized live chat is probably the better way to go. Top Chat filters my chat a little bit, so sorry about that. But I'm glad you repeated it. What good options out there for backup recovery with Docker for prod servers? And I'm going to come back down to your comment here. You skipped my question. What are good options out there for backup recovery with Docker? Okay, so same question. Great. I don't know about custom backup and recovery solutions for like a swarm. Kubernetes has everything in the world made for it. The entire internet is being replaced by Kubernetes projects. So all the open source we have is no longer good. We have to make Kubernetes versions of it. I kid, but that's also kind of been what's happening. It's a little insane. It's hard to keep up. I would say that backup and recovery is no different in Docker than, from a tooling perspective, than it was before Docker. There's actually in Docker Mastery, in the Q&A, there is a Q&A question around backups. And I'm trying to think if I have that in my AMA. Let's go check here. Yeah, so I have a question here. It's number 12 in the AMA. If you want to go check that out, it talks a little bit about it. But in essence, all your persistent data in Docker or in Swarm or anything, they should all be in volumes. So those volumes are just paths on the host operating system. They're just under var lib docker /volumes. And you just go and back up the data there. If you need to run a backup tool to do something special like a MySQL dump, that sort of thing, you would also run that in a container. And if you see my Docker, this is my old talk. If you were to go to my new talk, DockerCon, let's see, brettfisher.com/Docker. If you go to my second talk on DockerCon Part 2, down here, that shows off my dogs versus cat repo. And it gives a simple but accurate example of doing backups. And I do it in here. So zoom in for a second and just show you. Backups aren't as complicated as you think they are. You shouldn't be backing up images. Images should be stored in a registry. And that means that's someone else's problem to back up, right? So your images, you don't need to back up. Your containers, the only place in the container you should store anything you care about, persistent data, is in a volume, which means you only need to back up volumes. And if you happen to need to get data out of a database or something that's in a container into a place that's stable, because you don't want to usually back up a live database file, because that's an unstable file that you can't guarantee the restore of, right? So here's me running a MySQL database, very simple, has a password. And then here's an example of me running a very simple backup script that runs the MySQL dump. It's also pointed out to me that this MySQL dump command is not always exactly what you want to use, because this may actually freeze writes on your data and in your database tables. So I'm not giving this to you as a prescription. I'm giving this to you as an example of how a lot of people before, they had a fancy solution that basically just did a cron that did a MySQL dump onto some shared storage off the server, right? That's exactly what you would do now. You just wouldn't use cron. You can use, this one in particular uses a very simple bash shell loop that just says, while true, do a MySQL dump, and then sleep for 3,600 seconds, and then do it again. So it's a shell loop, and if it crashes or anything's a problem, because it's a swarm service, it'll automatically get created again. In this case, I'm running the exact same image. That way I get the exact same tool versions as is in my database, so that I can ensure compatibility. And then at the same time, I don't need to run it on the same physical container. I can run it on a container elsewhere on the swarm over the network, do the backup, store it on, in this case, we're doing a DB backup volume. And the example of this is I'm actually using RexRay with DigitalOcean block storage. So in this case, I have a dedicated volume for backups, and I use the RexRay driver to get me there. And then in my backup container service, I do the backup onto that. So presumably if I needed to do a restore, I would just connect that volume and then do a MySQL import. So it can get way complicated more than that if you want it to, but it doesn't have to. The rules around backing up persistent data don't really change. I hope that helps. And there may be third-party tools out there selling you a little bit of snake oil, saying, we are container ready. What I would say for them is that in large environments, if you have lots and lots of persistent data and you need to be on specific networks and run specific jobs and then track those database backups in a large volume, then yeah, you're going to need some higher level system. And they may, I mean, everything's got Kubernetes integration now, so you may look at a Kubernetes specific solution that will launch the container where it needs to be, and then do a backup. But I haven't had to use those yet for me or any of my clients. In most cases on projects I'm on, I'm always pushing them to get their really important persistent data off the container cluster and onto the cloud that they're on. Usually they're on AWS or Azure, and those already have database management solutions that they're using. So we don't tend to do a whole lot of backups of stuff like that. Typically it's simpler things like user file uploads. We just store those on EBS, so those are already protected in the cloud. If I was in a data center, they might be on iSCSI off my server on some large, something like NetApp or HP storage or something like that. Let's see. So we got next question, Seven. How about what are the recommended options for rolling update to a Docker Swarm service via CICD? Didn't find any info on that in your courses last time I looked. Options for rolling update to a Docker Swarm service via CICD. Okay, so first, that I have insane amount of detail on that in the Swarm Mastery course for rolling updates now. Just launched 2+ hours of content. I think I said that already. CICD, in that case, what it's going to do is most likely just SSH into your Swarm and run Docker commands, Docker stack deploy, and it's going to manage the image. So normally, the simplest method, let's say you have Jenkins. And I don't have an example for you, but let's say you have Jenkins and you have an automation and you're using the new, I can't think what it's called, the new workflow methodology that is better than just writing scripts. You would first set the images, obviously you're going to build the images in CI. You're going to push those after it's tested. Once it's tested successful, you'll push them to a repo, an image repository, whether that's Docker Hub or something. And then in that, the next step in that workflow for CI/CD is to set local environment variables in its tool, in its workflow for the images that you need to update to in your swarm, right? Then you're going to set those in the YAML file. Oh. Looks like we lost each other for a second. Sorry about that. I don't know what happened. We lost the stream for a second. Okay, so we're back, and hopefully you didn't miss too much of it. So you're going to, in the CI/CD, you're basically going to set environment variables that will then be used in your YAML files for your stacks as the image versions, and then you will redeploy a stack just using Docker Stack Deploy through SSH using your CI/CD. To me, that works great. The other way is to open up the TCP endpoint on your swarm for the Docker engines on your managers. That way you can run commands natively on your Jenkins or your CI/CD. That way is more work, and quite frankly, I'm not sure that it's better. So it just depends on whether you want SSH certificates or you want TLS connection certificates stored in your Jenkins solution. You know, it's up to you. But really, you're just having it run the commands for you. You could try to do stuff directly against the API without, like if you want to do a really bespoke custom solution, but I've not seen anybody need to do that really unless you get to sort of internet, what I would say, cloud scale cloud solutions. So I helped CodePen out, and CodePen runs a whole bunch of servers for putting front end code into a website. And they created a custom solution against the API simply because they needed to do things that were different than what the command line for Docker allowed them to do. So, and they want a different workflow that way. You don't have to do that, obviously. I don't think most people need to do that, and they just SSH in. Hopefully that helps. I did not talk about that SSH in the CI in my Swarm Master course yet, but that might be an upcoming section. Niraj asked about telling us about storage drivers. I think I did, so hopefully I covered that. Nitish, you said Red Hat OpenShift is a wrapper over Kubernetes open source. How can you take an open source project like K8's, create a wrapper product around it, and sell and make money out of it? Everyone does it. Everyone does that. It's a great question, but Docker EE is exactly that. Rancher is exactly that. Rancher doesn't necessarily make money on the product, but they make money on the consulting for implementing and managing the product. OpenShift does that. That's exactly what open source is designed to do, right? If you've got an MIT or Apache licensed product, anyone else can take it, turn it into something, and sell it. And that's the great benefit. That's how we have Red Hat. I mean, the entire existence of Red Hat as a company is based on that model. So I think it's a great thing because it gives us choice. If you don't want to pay for something and you want to do it yourself and you want to spend a lot of time on something, go open source. Typically, buying products that are based on open source will save you time but cost you money. My argument a lot of times is that for businesses making money and using products in production, the pure open source way is often not the best way, because what is the biggest limitation in most cases in companies? It's not money. If you're in a big enough business, it's not money that's the problem. It's people, it's staff. It's getting enough human resources that are smart at DevOps and running, CI/CD pipelines, right? So if those people are more valuable than a few extra dollars, I usually recommend go the paid route. Use Docker EE. I haven't run OpenShift, so I don't know anything about it other than that it's using upstream Kubernetes like everybody else. But if you go look at the marketplace now, you see that everybody's talking about, we will, if you want to do Kubernetes on Mesos, it's using upstream Kubernetes. And OpenShift actually is one of the few that still has a fork. So they've changed Kubernetes to do what they want to do. And they, for better or for worse, they're not using pure Kubernetes. They're using a custom Kubernetes solution. Rodrigo, hi Brett. Greetings from Brazil. Hello, Brazil. Would be too much to ask for the Docker bookmark for that Docker bookmark folder. Oh, in my Chrome, I don't. Tell me how to get it to you. How do I do that? I don't even know. There used to be a really cool tool. I think it was like Xmarks for syncing that, and there was another tool on the internet for I think it was like for syncing your bookmarks to a website, but I don't know that any of those exist. Share with me in chat how you would like to get them, and I'll figure out a way. I'm not going to promise that there's anything in there. Probably half the links in there are broken because that's the internet, but sure. Bradley's answering the Red Hat question. Yes, thank you. Once inside, Natish, once inside a container, is there any way to figure out if I'm running a VM or bare metal? Maybe, but not likely. I don't know off the top of my head, quite frankly. Maybe, I don't know, maybe some kernel indicator that indicates, but I don't, quite frankly, I'm not sure that there is, but. Hans, latest CentOS 7 also uses overlay 2. Yes, it does. Where there'll ever be a Kubernetes integration for Docker CE on Linux as on Windows and Mac. That's a great question, Hans. As I think what you're asking is, there's Docker. What we call them now is the Docker's renamed them as Docker Desktop. Docker Desktop is Docker for Mac, Docker for Windows. There is no Docker for Linux. Every time, and I'm saying like every time we have a DockerCon, we have a captain's feedback, whatever, someone asks for it. Can we get a Docker for Linux? The reality, I think, Docker's not saying no. They're just saying it's on our list. We'd love to do it. We just need the resources and time to do it, and we haven't been approved for that. I think the problem really there is that people that are running Linux desktops, let's just say, of all the people using Docker are maybe like 2%, 70% Windows, the rest is Mac. So you're unfortunately, and this is just reality, I wish that we had it on Linux and FreeBSD, which is one of my favorites. And there's just such a small market for it that I don't know if there's going to be anything ever done by Docker. If it is done by Docker, it's probably not going to be soon because it has not been approved for them to work on, even though they all love the idea and would love to work on it. Right now, like a Docker, they're hiring like crazy. They're over 300 people. I think they're 350, possibly even 400. And they're just trying to focus on getting the quality of their products and the feature set to where they need to be in order to be around, right? Like they're a 5-year startup that needs to survive in a marketplace where they're competing with Red Hat and Google, and that's a tough market to be in. So I would say great, cool projects like that aren't necessarily going to win them any more points because you're already using Docker on Linux. So Docker GUI on Linux isn't really going to help them. And I guess the other thing is a lot of their paid customers, Docker EE, are not enterprise desktop Linux. So those people would need to start requesting it a lot in order to get them motivated around paying customers. There's been lots of rumors, though. Like there's a rumor that they would have a paid version someday of Docker Desktop where, if those of us that wanted Docker EE enterprise versions on our Mac and Windows locally for development, but that hasn't come to pass either. So who knows? There's probably some stuff out there that would help you with the GUI that you could check out. So to speak on your Kubernetes integration part, what he is actually asking about, I believe, is, for example, on my Mac, there's this Kubernetes option where instead of using Kubernetes tooling to spin up a Kubernetes cluster like Minikube, I can now just click a box and Docker will set up the Kubernetes cluster on my machine locally, just like you can do with Swarm, and you can actually toggle back and forth. In fact, right now, there's some patches to allow, I don't know if they're actually in the release, but you can now run Swarm and Kubernetes at the same time and switch and do Docker Stack deploy deployments to both of them, which is amazing. I don't know if that's actually in I just saw the commits the other day. I don't actually know what version they're in or if they're out yet in production, stable versions. So the real question there is like, can I do Kubernetes on Linux? Can I have Docker set up Kubernetes automatically on Linux and manage it? The answer is unfortunately no. But if you didn't know it, if you're on Docker CE, when you do Docker Stack deploy, you could actually have it go against a Kubernetes orchestrator. So see here this option when you do a Docker Stack deploy now. This is a new thing. This is not yet in my course because I don't really teach Kubernetes yet. That's coming. But there's the option there to choose your orchestrator. If you have Docker talking properly to a Kubernetes cluster with Docker CE on Linux, if you've done Minikube locally, you could potentially use the Docker Stack deploy command against that local Minikube. I don't think anyone's done this. So what I think is it's technically possible to do this, to set up Kubernetes on any system without Docker's help and have the Docker CE command line deploy stack files against it, which would be really cool if you didn't want to use Helm charts, for example, and you just wanted to stick with compose files. I don't know that anyone has done this testing and done a great demo. So that's something in the community to play with, right? Docker CE can talk to a Kubernetes cluster now, talk to the Docker, to the Kubernetes API. It's just not well documented yet. At least I haven't seen it. It's probably out there somewhere. So you might be able to get that all set up and then be the first one to have an amazing blog article that will make all the captains jealous because they didn't do it first. Natish, thanks, but then why won't Google themselves do it and rule the world? Sledjan, is that how you say your name? I'm sorry if I'm mispronouncing that. Apologies. Thank you so much. Thanks for your time, and you're doing a great job. Thanks. I'm glad I'm explaining it well because that's what I always wish I had, right? I always love it when people can explain things really well to me, and I always try to do better at doing the same for others. Tommy, I've had problems with Docker for Mac. It's really slow. As far as I know, this problem is because of disk performance. Have you had the issue, and have you found any solution for this? So Tommy, your disk performance issues, if that is what the problem is going to be very, very specific to your project, your hardware, your versions, all that stuff. So what I would say is, Tommy, if you're in the Docker Mastery courses and you have access to the Slack channel, ping me in there, and I can give you some tips. I don't have like an obvious fix. If you're on Docker for Mac, I'm assuming, and you've done research on this, I assume that you know about the switches in your compose files. So here in the documentation, Docker talks about your volumes and your bind mounts and how, because the biggest problem on Mac and Windows in general is when you're bind mounting host files. That's technically files on one operating system being connected to the other file system inside the Linux VM. That's always going to be slower than native OS because you're talking about two different OSs sharing file system commands, right? Nothing we can do about it in terms of making it identical in performance until we get to the one OS where you're only running on one OS and you're not bind mounting across. Otherwise, there are options down here. They talk all about it, but when you volume and you have these three different options, consistent, cached, and delegated, those options you should research. If you went and looked into my Node.js project, for example, I enable the delegated mode in Node to make Node faster in Docker Compose. So in this project, you'll see that we had this volume mounted, and that's me mounting in the code using the Mac-only option delegated, which speeds up the file read-write performance on my Mac uniquely I'm assuming you know about that stuff just because if you blog around for a little bit, you end up finding it that this supports in Mac. If you have other specific issues with specific projects, please ping me in the Slack chat or on Twitter or something, and we're going to have a conversation about what you've tried, what you've done, because there's lots of stuff there. Obviously, the latest versions of Mac, you have to be on an SSD hard drive. Like if you're on anything other than a pure SSD, it's going to be slow on anything you're doing. It's just going to be even slower on Docker. You got to have the latest version of Docker, and then obviously using the delegated if you're talking about bind mounts. And then from there, we start to get into project-specific stuff, like how often are you doing your npm installs or your gem installs or your Python pip installs. Maybe we can have those done less often because that's usually what takes so long are the application module installs, and that slows things down a lot. And so let's see if we can't prevent you from having to rebuild those all the time, right? Because ideally throughout your day, you're developing and you're not having to rebuild images all the time. You're just developing locally. So yeah, great question. It's just not always an obvious answer on how to make it better. All right, this is going to be the last question because we have hit the hour, but we're going to be back here next Thursday at the same time, hopefully. And I will put a reminder on YouTube. So if you're subscribed to the channel, you can get a reminder. But let's go for the last question here. Vladimir, hopefully I'm pronouncing that right. Vladimir asked about CentOS kernels, 3.10 kernel. You can use a 3.10 kernel. That is technically compatible. However, it is older than the Docker project itself. 3.10 is over 5 years old. It's insane old in the terms of the internet. Like, think about what we didn't have on the internet 5 or 6 years ago. A lot of things didn't exist, including Docker. So I always recommend a 4.x kernel. The latest version of CentOS 7 has got a horribly old kernel, and if it was me deploying, I would either find a different Linux distribution or I would find a way to get a 4.something kernel in CentOS. I can't count how many times people have come up to me and said, we had problems with the 3.something kernel in our deployments, whether it was in production Swarm or production Docker in general. And then we fixed it by going to 3.17 or 4.10 or whatever. So that's just because even though Docker is compatible, it doesn't always mean it's going to perform well or that things will happen perfectly the way they're supposed to because no one's testing on those old kernels anymore. Well, Docker maybe is doing some testing just because they say that they're compatible on 3.10 forward. But compatibility does not equal best, right? And when you're looking for the best performance and the best compatibility in terms of all the latest features, I would always recommend a 4.something kernel. That is a great question, and unfortunately, if you're stuck on the 3.10 kernel, you just have to live with it. And if you can't change it, if you can't lobby for better stuff, people always ask me, well, what are the issues that you're going to run into? Disk I/O issues, writing issues on the overlay 2 or the storage drivers. I don't remember specifically most of the things because those were projects I did 3 years ago when people were more commonly using a 3.something kernel before we had really good solid 4.something kernels in every other Linux distribution. So I'd say that nowadays I'm not on any projects that deal with 3.something kernels anymore. But every time I mention it in a talk at DockerCon, someone always comes up afterwards and says, yeah, we had problems with a 3.something kernel and we moved to 4 and the problems went away. I don't get to learn all their problems and like exactly what the issues were, but usually I think that in those cases it was resulting around not necessarily something that was Docker's fault. It's just something that was either buggy or not as well developed in the Linux kernel or the Linux kernel modules that got better fleshed out. Because the reality is that containers are so popular on Linux now, they're affecting future kernel development. And so in the 4.something kernel line, that's what we started to see was more and more influence of container workloads, namespaces, C groups, and all the other things affecting the priorities and the stuff going on in the Linux kernel. Now, that being said, I'm not a kernel expert, so these are just things that people that are experts tell me. about Linux kernel development, but that influences my decision because when I look back, 3.10 came out the year I think before Docker even was released. So the fact that we have influence now in the containers in the kernel as a container ecosystem, to me means that there are definitely improvements and advantages to using a 4. something kernel. The challenge with 3. something kernel is if you ever get into muddy waters where you're having problems, you're not going to know, is this a Docker problem? Is this because I have an old kernel? What is this my application? What is the problem? And so in those cases, I would personally, if I was forced to use 3.10 in production, I would have a mirror system somewhere, even if it was just on my local machine. I would be using a modern kernel. And when those issues happen in production, I would try to emulate that same problem on my 4. something kernel test system. And a lot of times, unfortunately, that's performance-based, so it's really hard to get performance-based problems to show up in test, right? We all probably been there. So I would do that and at least try to emulate the environment and say, hey, look, I can't get this problem to happen on 4. something, but we can make it happen on 3. something. Maybe you're that lucky and you can prove that 4. something is better. Otherwise, you might just be stuck there. So sorry for that. Thank you, everyone, for coming. Again, check out my stuff at brettfisher.com/Docker. That's where I think I put everything. I referenced everything today is all linked there, all my projects, all the samples, all the videos. And I will see you next week in another Docker Q&A Live. Thanks.